All right, everybody, so thank you for coming. This is the ROS Industrial Community Meeting for June 2020. We'll touch on so basically a welcoming. Obviously, we'll probably still have some folks trickling in, which is great. That's totally fine. My name is Matt Robinson. I'm the program manager for ROS Industrial Americas, the consortium here located in, we hub it out at Southwest Research Institute down here in San Antonio, Texas. We're going to give a little bit, kind of some things that are going on. And then, of course, I'll kick it over to Levi to share some of the technical happenings here in a couple minutes, right? And then after that, we'll kick it over to Asia Pacific. Eric is kind enough to stay up late to share kind of what's going on over in the Asia Pacific region. They're based out of ARTC in Singapore. And then Christoph Hellman will give us a little bit of update what's going on in the EU from the Fraunhofer IPA side of Stuttgart. And he's invited, and we're happy to have Felix Exner from FCI share some work that's going on about a standard Cartesian trajectory interface for ROS. So that's pretty exciting. Then we'll go into a couple of member presentations. Canonical's Adi Singh will share a little bit what's going on around securing robots for the long term. So some of you may have noticed Canonical's been sharing some updates via Discourse and other social media about some work they've been doing on security and supporting a security working group for ROS-I. So that'll be very interesting. And then, of course, with all the activity around Move It 2, the recently announced Rosen project supporting Move It 2, it seemed fitting to have Henning Kaiser come today and share a little bit what's going on relative to the ROS-I work. Any questions about the agenda? Hopefully our other speakers make it here. So anyways, so as a number of you know, here in the Americas and ROS Industrial, our global level, we've been really taking a look at, it's no longer novel, right, to use ROS to make an industrial robot move. Years ago, there was like, you get a lot of eye rolling or confused looks if you say you're going to pull something down from the internet and move an industrial robot with it. So since we've overcome that hurdle, over the uneasiness or the just general acceptance that ROS is a viable way to develop advanced capability, we've been really thinking about these sort of three high-level things: quality, improved user experience, and of course the capability, the robot's doing new things. And how do we represent that, right? So the whole point of a consortium, as many of you are involved with and know, or at least aware of, is the consortium is basically this conduit of member feedback, driving kind of example use cases, incentivizing OEM engagements, standardizing interfaces like we're going to hear about on the Cartesian interface, and help set the roadmap and direction. And when we talk about interoperability, it's even then making a broader impact across the whole value stream. So I just wanted to remind and level set. And though we are a global project, obviously each region has its own focus. It gives us, the ROS Industrial Open Source Project, greater flexibility to be somewhat a federation of 3 different regions, because each region will do its own initiatives. As you'll hear a little bit about when Christoph talks, he'll talk about the Rosen initiative, right? And that's obviously something that they've been able to morph and adjust and pivot their consortium strategy to take advantage of to great success and benefit to the whole ROS Industrial Open Source Project. Similarly, in Asia Pacific, Eric might share, I don't know if it's on topic for today, but Eric has very often shared a lot of the work that's going on in medical around IoT and how ROS-I is becoming a good candidate framework to enable really rich IoT applications, not just the robots like we tend to think about and talk about, but that broader stitching together your whole application space. Similarly, in the Americas, we've been taking advantage of the MIIs and opportunities to inject novel capabilities leverageable by a broader community. So of course, these things, obviously, they all feed our training, and that becomes sort of basically totally available to the open source community, and it's iterative and global. And we try to make sure there's some level of consistency, though there are variations, again, because the different regions have different interests. So with that being said, as we talk about the capability, right? Capability tends to spawn the training, right? It drives needs, it drives questions. We can have something really interesting and exciting, but if no one can use it, it doesn't really make an impact. And then for people that like, say, pull the purse strings, if you will, or make some of the decisions, drive investment, we sometimes need that watered down basically the business case sort of things, and of course resonating success. And some of you may have seen the recent blog post on ROS Industrial's website about Street Scooter. We're trying to get more of those sort of successful case stories out on the website where they're very easily available. And we're going to have some more news about reinventing the website in the coming months, so keep an eye out. More tightly coupling the development going on in the open source repos with kind of this easy to digest stuff that's on the website. So anyways, getting into like more of the Americas update. Our first online training, right? So I believe a couple of the other regions have also been exploring online training, or maybe you've even hosted one by now. But we were going to do our first Americas online training July 21st to the 23rd. A number of people have inquired about it because it is on the website, and I've communicated it via our Americas members updates. We're going to be basically doing this via the AWS EC2 Ubuntu desktop instance. It will require everyone who comes to training to create an AWS login, but at the same time, one of the big issues we've had is deploying virtual machine is that there is some sort of basically difficulty sometimes for the students to configure the virtual machine. In some cases, they cannot, or they're restricted due to the configuration of their laptops from their employers. So the EC2 instance enables all of this. It's like a clean, you still have to go through all the machinations of installing ROS and getting it up and running. And then we're still revisiting for those who maybe want to leverage a virtual machine to have something, so to speak, to take home. Maybe that's something we can do as part of the lab day. And we're also investigating, basically the workflow will be, it'll be a basic ROS 2 intro, and then some sort of like facilitation between Mood and Move It 2. We're still working out the details of the agenda. I hope to have something by the end of next week, at which point I will also open up registration. And we're still working on class size too, so bear with us. ROS-I Day is fast approaching. It's hard to believe, July 7th. There's an event posted, and I believe the newsletter out of Asia Pacific mentioned it as well. So we're excited to be organizing that. We've got some homework to do before we can blast a full set of information, but hopefully you're all looking forward to that. We'll be working with the Robotic Industries Association, a webinar on July 13th. That'll be all the consortium representatives, Eric, Christoph from Fraunhofer IPA, and myself. We'll be, I believe that's at 10 a.m. Eastern time, so it's 9 Central. So it's basically this same time. RAA is the Robotic Industries Association, it's a trade association that does serve global. They have members from around the world, and they organize a number of different events, such as Automate here in the US. It's probably one of their most well-known ones. And then Levi Armstrong is going to be speaking on August 19th on the hardening of ROS Industrial for robotics applications. Some of the key technologies and the impact they're making. He'll be speaking on August 19th as part of the AWS Cloud Robotics Summit. So we'll try to get that up on the ROS-I website as well, along with the information on how to catch that. Some of you may notice over on the blog, there was a pretty detailed write-up on some recent work that's been open sourced, at least preliminarily, so for people can experiment with it, about leveraging machine learning and classifiers for 2D data and overlaying them on 3D data. In this case, it's a application to find weld seams, right? So basically we take 2D data that's been trained up, where we've classified different intersections of plate materials, and then overlay those to do basically, the long-term goal is to do machine learning based feature classification to actually drive your intelligent processing. So that's a pretty exciting write-up that was also presented at the Tech Connect AI conference recently as well. And of course, this has now been reposted a number of times. This was picked up by the Robot Report as well, an initial implementation. So for those who don't know, we currently have an active project we're developing in the open source in ROS 2 for what they call collaborative robot sanding. And we can all debate about whether sanding is ever really collaborative, but anyways, notwithstanding, there is a full project being built out in ROS 2. And so Jorge Nico, a developer here on our staff, implemented basically scan path motion planning using Move It 2 as an example, and then did a write-up about it and created a short video. So that's over on the blog as well. With that, I'm going to hand it over to Levi. Levi, I'll stop sharing, and you can take over.
So I'm going to cover some of the technologies we've been working on here at SWRI through our research and development program. R&D funding program to expand scan and plan capabilities. We just wrapped up an R&D project to explore the use of this heat method. It's a unique method that providing a heat source on a mesh, you can use unique capabilities to get equal distance isolines over a mesh. And you can provide your own heat source, say like a point, an edge, or you can draw your own line. So most of the work on this was to take this existing approach and develop a way to extract those isolines. The original implementation more or less just leveraged a texture map to color the images you see in the top right. There was a lot of work to go through and extract that. The image on the bottom left is an example of providing the heat source, which is the red lines on the left of that, and you can see the extraction on the right of those ISO lines from that. The idea is to leverage this for generating toolpath. This approach seems to be pretty robust to noise compared to existing math, and it'll work on point clouds, octomaps, and along with meshes too. So I think there's current work to integrate this into our offline planning tool that we have, GUI tool, but we just wrapped this up. Another research and development project we just finished was looking at the possibility of achieving like near real-time motion planning, online planning for adaptive motion control. So we did a lot of work here. The work you're seeing right now was done by Matthew Powelson. He went through and as part of this, so this example right here, it's regenerating the robot trajectory around 500 to 1,000 hertz. And you can adjust the step size for how quickly it changes the trajectory. So you can see it, so it moves pretty quickly based on this cylinder moving through. This is a 2-axis gantry with a 6-axis robot. There's an example in Tesseract ROS that kind of shows how you might use this. I'll go into a little bit more detail. As part of that, we did a lot of benchmarking. We were looking at could we leverage GPU to accelerate this. What we found out is for the type leveraging optimization, the type of matrice size that you have in those, like for kinematics, smoothing, and things like that, that they're small enough that leveraging the GPU is not beneficial for that case. That it's better to probably leverage the GPU at the solver level, like the SQP solver and things like that. And there are several of them. OSQP is has a GPU implementation for that. Because of that, we settled on using an eigen implementation called IFOPT. It's open sourced and available to build out this motion planning framework for optimization motion planners. That is currently under TrajOpt IFOPT, and available to be used. Another effort that we did, most people are aware that most of your time is spent in collision checking. So we did a lot of collision benchmarking of our existing contact checkers, and also implemented a CPU along with a GPU implementation of a new collision checker that is internal to SWRI. When we did this, most of our optimization on our original collision checker was to support TrajOpt, which needs all contacts and their distances. In this, we found out that in cases where you wanted to use like OMPL or Descartes, things that you just want to detect contact first, you don't care about all of them. It wasn't optimized. So we went through and re-optimized all of the contact checkers. So you can see on the left was the original, and on the right is the optimization changes we made to improve it. So it was basically an environment of 100 collision objects, the same collision object, but scaled of different sizes, and then we randomly chose 50 robot states, and we make contact requests, and we did that 1,000 times. So you can see on the y-axis is your contact requests per second. So if you only care about the first contact only, we were able to achieve between 8,000 to 12,000 checks a second. If you're interested in distance, all the distance information, we're able to do that around, for the open source versions, you can get a little over 1,000 checks a second. With our internal CPU/GPU, you're able to get about a little over 2,000. We did find that the GPU seems to be pretty flat, but it doesn't pass the CPU implementations until you get over like 64 links. Once you get to larger environments, the GPU implementations of this collision checker significantly starts to surpass CPU implementations once you get to larger environments. And it more or less just stays flat. You see little degradation as you increase the number of links in your environment. Another effort, this is a command language to support ARM project that we're working with RPI on to develop an open source teach pendant. The ideas behind this is you can kind of build out a teach pendant type program, but be able to leverage the advanced capabilities of our motion planners. So the idea is you not only define motion instructions, but you also want to incorporate IO variables, standard information that you would typically do in a teach pendant. So this is available to be used. We're working on it. We should have this wrapped up by the end of the month, I think is the plan. But the idea is you can kind of write out this simple program, and it flows through goes through motion planning, maybe through some other process steps, and then execution. And our plan is to hopefully have an executor on that controls a robot that can interpret this to not only do motion execution, but set IO tool changes and things like that. And the way we incorporated the advanced capabilities of motion planners, you kind of define these profiles. If you're familiar with like ABB or those motion modifiers, like you have continuous 100, continuous 10, or any of the others, that's kind of what these profiles are. You'll have like a toolbox of these different profiles that define different types of costs and constraints on these individual motion or planning instructions. And then we'll have a controller on the execution side that can also interpret those for the execution. We also implemented like a Tesseract setup wizard, similar to the Move It setup wizard that allows you to configure properties specific to the Tesseract environment. I want to acknowledge Louise and Kyle. Louise from Open Robotics that helped with ignition components, and then Kyle from Canonical. We're planning to release this as a snap package to make it easier. So we kind of adopted ignition rendering and ignition GUI for the visualization engine for Tesseract. It provides, if you're familiar with Gazebo, it provides a very rich simulation environment. But these are just different things you can define. Pick your URDF, SRDF, define the allowed collision matrix. You can set up kinematics, defining mesh joints, chains, links, define joint states. You can also define TCPs similar to what you define on a robot controller, a standard industrial robot controller. We created a utility to easily define OPW kinematics. This is a library out there that allows us to implement as a closed form IK solver for your typical industrial manipulators. Next, we have some current research that is ongoing. We have one around robot calibration that's expanding on industrial calibration and robot cal tools to one be leveraged to calibrate robots, but also improve the debugging aspect of the library to provide information to help you identify high correlations between variables and things, so you can make adjustments for those. Another one is around process orchestration. This is more of a high-level process planner that can handle a lot of different tasks and come up with the most optimal way to do the motion planning and also execution. And the plan is for that to be highly parallelized, to be able to quickly do all the motion planning very quickly. And I think most of these two wrap up the end of the summer.